Chapter 10, Section 1, Power Series. Here's the definition. We say a power series centered at x equals 0 is an expression that looks like this. Sigma c subscript n, c meaning a constant, times x raised to the n going from 0 to infinity, which means c subscript 0 times x to the 0 plus c sub 1 times x to the first plus c sub 2 times x to the second plus dot 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 c sub n times x to the n plus dot dot dot. A power series means the terms have powers of x. X to the second, x to the first. The first term has x to the 0. You can't see that because x to the 0 is 1. A power series centered at x equals a meaning any number, would look like this. Sigma c sub n times the quantity x minus a to the nth power and going from 0 to infinity, which means c sub 0 times x minus a to the 0 plus c sub 1 times x minus a to the first power plus c sub 2 times x minus a to the second power plus etc. c sub n times x minus a to the nth power plus and so on. So this is called a power series centered at x equals a. If all of the a's were zeros, we'd have what's above here called a power series centered at x equals 0. So I'll repeat, a power series just means each term has powers of x with some constant multiplied to each term. First term has x to the 0 power, the second term is x or x minus a to the first power, x or x minus a to the second power, and so on. So I think we're going to look at page 485, exercise 22. Sigma n equals 0 to infinity, negative 1 to the nth power times x plus 1 to the nth power. This is an example of a power series. And if you want to be specific, I could say it's a power series centered at x equals negative 1. Because in the parentheses, I see x minus negative 1. The directions for this exercise are find the interval of convergence and the function of x represented by the geometric series. So we are informed in the directions that this is a geometric series. That means there must be a common ratio. If we were to write out the terms, you would be able to see that there's a common ratio. And I'm going to rewrite this as, since both of these are to the n, we can write that as what's in here, this base times this base, which is negative x, negative 1, the whole thing to the n. Since both of these are raised to the n, we can put these together. And from this, we can see that the common ratio is negative x, negative 1. And a geometric series will converge when the absolute value of r is less than 1. In this case, we need the absolute value of negative x, negative 1 to be less than 1, because r is what's in the parentheses here, the common ratio. To solve this inequality, we learned this in Algebra 2 trig. To solve an absolute value inequality, we say what's inside the absolute value has to be between this number here and the opposite of that number. Let's add 1, which means we'd have to add 1 over here and also over here. Negative 1 plus 1 is 0. Copy. Negative x minus 1 plus 1 is negative x. Copy. 1 plus 1 is 2. And now we're going to divide each term by negative 1. 0 divided by negative 1 is 0. Negative x divided by negative 1 is x. 2 divided by negative 1 is negative 2. When we divide by negative, the inequality reverses. So 0 is greater than x, and x is greater than negative 2, is the same as, put this over here, put this 0 over here, but the graders would change to less now. We call this the interval of convergence. That means these are the x values. That would make this series converge. This is a geometric series. It can only converge when this is true. And in this exercise, the absolute value of r is only less than 1 for these values of x. We call that the interval of convergence. And the sum of a geometric series that converges is a over 1 minus r. So sigma negative 1 to the n times x plus 1 to the n going from 0 to infinity will be equal to a over 1 minus r for the values of x for which it converges. A means the first term. A means, A right here, means whatever this is when n is 0. And negative 1 to the 0 times x plus 1 to the 0 is 1. Anything to the 0 is 1. 1 times 1 is 1. R is, as we saw on the previous board, negative x, negative 1. So right here it says R, negative x, negative 1. So we simplify this. We say that's 1 over 1 plus x plus 1, or 1 over x plus 2. So this infinite series and this function, I'll call it f of x, 1 over x plus 2, are equal for these values of x, which we call the interval of convergence. I think we answered the exercise. The directions are find the interval of convergence. We got that. And the function of x represented by the geometric series. This is that function of x they're asking for. All right, now we're going to do number 28, which says use the series and function f of x from exercise 22 to find a power series for f prime of x. we're going to start with what we got in exercise 22. We found that f of x was equal to 2 over x minus 1. And we said that that's the same as sigma this is error, sorry. Let me look back here. F of x is 1 over x plus 2. And that was the same as sigma negative 1 to the n times x plus 1 to the n, and going from 0 to infinity. So we found a function that we decided to call f of x, and it represents this infinite series. We are now going to take the derivative of both sides, or all three of these. The derivative of f of x would be, actually before we do that, we're going to rewrite 1 over x plus 2. We're going to write it as 1 times x plus 2 to the negative 1. And this, we're going to rewrite that as 1 minus x plus 1 plus x plus 1 squared minus x plus 1 to the third plus dot 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 plus negative 1 to the n times x plus 1 to the n plus dot dot dot. So f of x is 1 over x plus 2. That's the same thing. This series, when you replace n with 0, you get 1. Replace n with 1, you get minus x plus 1. Replace n with 2, you get positive 1 times x plus 1 squared. Replace n with 3, you get negative 1 times x plus 1 to the third, and so on. This goes forever. So now we're going to take the derivative of each part of this equation. The derivative of f of x would be f prime of x. The derivative of this would be negative 1 times 1 times what's in the parentheses raised to the negative 2 times the derivative of what's in the parentheses. By rewriting it, I avoided using the quotient rule. The derivative of this, and all three things here are equal, so all three of these will be equal. The derivative of this is 0. The derivative of 1 is 0. The derivative of negative x, negative 1 is negative 1. The derivative of this next term is positive 2 times x plus 1 to the first power. The derivative of this next term is negative 3 times x plus 1 to the second power plus dot dot dot. The derivative of this nth term is the exponent times the number in front. That would be n times negative 1 to the n times x plus 1 raised to the n minus 1. Etc. And I'm going to just rewrite some of this. We've actually already answered the question, but I'm going to rewrite this a little simpler. F prime of x. This expression here can be written as negative 1 over x plus 2 raised to the positive 2. And this over here, where I have all these terms written out, can be written as sigma. I'm going to write this nth term right here. Negative 1 raised to the n times n times x plus 1 raised to the n minus 1. And you're going to think about why I'm starting with n equals 1 instead of 0, even though the original function from exercise 22 started at n equals 0. There's a reason this one starts at n equals 1. I would just like you to think about that. And an important rule that I haven't mentioned yet is if we have a series with a specific interval of convergence, its derivative will have the same interval of convergence. I'll repeat. Start with a function that has a specific interval of convergence, which we know from exercise 22. If we differentiate, we get a new function, a new series, but it will have the same interval of convergence as the original. So the interval of convergence for this series is just like in exercise 22, -2 to 0. So I think we're done with exercise 28. Let's read the directions. Use the series and function f of x that is represented from exercise 22 to find a power series for f prime of x. This is it right here. This is what they're asking for. This is the power series. If it asks for the interval of convergence, we would just say it's the same interval of convergence of the original function, the function that this is the derivative of. Okay, next one is number 24. Ready? Number 24. It says sigma 3 times x minus 1 over 2 to the nth power. Notice the 3 is not to the nth power here. N equals 0 to infinity. So our directions are, let's look back and see what we did in number 22. It is to find the interval of convergence. This is a reminder of how we did that. And the function that this represents. We know this is geometric because it says it right in the directions. So we're going to note that for convergence, the absolute value of r has to be less than 1. In this case, the absolute value of r has to be less than 1. This thing inside here is what r equals. To solve this algebra 2 inequality, we say what is inside the absolute value has to be between this number and the opposite of that number. I'm now going to multiply by 2. 2 times -1 is -2. Copy this. 2 times this fraction is x minus 1. Copy that. 2 times 1 is 2. And now I can add 1 if I want to, as long as I add 1 over here and add 1 over here. 2 plus 1 is -1. Copy. X minus 1 plus 1 is x. Copy. 2 plus 1 is 3. So that's called the interval of convergence. And for those values of x, the series will converge to a over 1 minus r. A over 1 minus r. A means whatever the first term is. The first term meaning all that right there when n is 0. All that in the red when n is 0 is 3. Anything to the 0 power is 1. 1 times 3 is 3. So a over 1 minus r. R is what's in the parentheses, x minus 1 over 2. This right here is x minus 1 over 2. If we multiply this numerator, if we multiply the denominator by 2, we'll get 2 minus the quantity x minus 1. If we do that, we have to multiply the numerator by 2. 6 over 2, this minus gets distributed. It's minus this whole thing, not just minus the x. 2 minus x plus 1. And so this equals 6 over 3 minus x. going to summarize the results so far. We've got, this is a summary of what we found. Sigma 3 times x minus 1 over 2 to the nth power, and going from 0 to infinity, is exactly equal to 6 over 3 minus x for these values of x, negative 1 to 3. Negative 1 less than x less than 3. I think that's all exercise 24 is asking for. Find the interval of convergence. We did that. And the function of x represented by the geometric series. That's the function of x represented by the infinite series. All right, now we're going to use this to do exercise 30. Exercise 30. So I start by writing down what we just wrote. We have some function of x. You can call it anything you want. I'm calling it f of x is equal to 6 over 3 minus x, which is equal to sigma 3 times x minus 1 over 2 raised to the nth power, n going from 0 to infinity. Let's rewrite this. We'll say f of x can be written as 6 times 3 minus x to the negative 1 power, instead of writing 6 over 3 minus x. And this series expanded out by making n 0, then 1, then 2, and so on, is 3 plus 3 times x minus 1 over 2 to the first power, plus 3 times x minus 1 over 2 to the second power, plus, etc., 3 times x minus 1 over 2 to the nth power, plus, etc. I think I'd like to rewrite this even another way. So I'm copying all of this again. I like to write it in a way that would be easier for me to find the derivative. So 3 plus, this middle part here can be written as 3 halves times x minus 1. This next could be written as 3/4. This 2 gets squared. Giving a 4 on the bottom times that 3 times x minus 1, which is squared, plus dot 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 3 over 2 gets raised to the n power times x minus 1 raised to the n power, and so on. Now that we've written what f of x is, we're going to differentiate. The derivative of f of x is f prime of x. The derivative of this is negative 1 times 6 times what's in the parentheses raised to the negative 2 times the derivative of what's in the parentheses. And the derivative of the other side is 0 plus 3 halves plus the derivative of 3 halves x minus 1 is just 3 halves. The derivative of 3 is 0. The derivative of this term would be 2 times 3/4, which is 6/4, which is 3 halves, times x minus 1 to the first power, plus dot dot dot, plus the derivative of this general term is the exponent times this number. That would mean it's 3 over 2 to the n times n times x minus 1 to the n minus 1 plus dot dot dot. All right, so I'm ready to summarize all of the results. F prime of x equals, this middle section here has a negative times a negative, that would be a positive 6. And you can put the 3 minus x to the positive 2 in the denominator. So the next one is not negative anymore. And this series, this infinite series, can be written as sigma n equals 1, not 0 anymore, to infinity of this general nth term, 3 over 2 to the n times n times x minus 1 to the n minus 1. And the interval of convergence would be the same as the interval of convergence for the original function. The original function came from exercise 24. Interval of convergence for exercise 24 goes -1 to 3. This function, which is the derivative of that one, will have the same interval of convergence. -1 less than x less than 3. The end.